Hey guys, so today I'm gonna start a new topic on force and pressure, and this is more towards the GCSE, so year 11 level. Okay, so pressure. So pressure has to do with force and surface area. That's the first thing you need to remember, because when you're answering these questions, you need to think about the force and surface area, and you can explain pressure or the uses of certain things. So that is basically the secret. Okay. So, pressure at surfaces. If you want to measure the pressure at any surface, what you need to do is to calculate the force over the area that the force is being applied on. Okay? So, the pressure comes in Pascal, which is the PA, which is the same as saying Newton per meter squared. And this is because forces comes in newtons, and the area, the surface area where the force is, being applied comes in meters squared. So pressure is newtons per meter squared, or Newton meter square minus 2, or then Pascal. Okay. So again, pressure comes in newtons per meter squared, or newtons meters minus 2, or then Pascal. So I said meter square minus 2. So to try to understand pressure, and we know that it's force over surface area, let's try to do this exercise. So again, pause the video, try the exercise by yourself, otherwise I will move on and then you can listen to the answers. So what I was asking you to do, or what I'm asking you to do right now, is to try to explain the everyday uses that I have for the four things that show in the picture, and use the words force, pressure, and contact area. I have a large train, obviously a very heavy train. Look at the properties of the train. See if you can figure out anything with force, pressure, and contact area. A surgical knife. Again, look at force, pressure, contact area. I have a hammer and a nail, and I have a caterpillar. So I'm going to go on the answers now. So if you want to try it yourself first, then pause the video, okay? So what happens is the pressure is the amount of force that is pushing on a certain area, right? And the size of the pressure that you are going to apply is going to depend on the size of the force and the contact area that is pushing on, okay? So imagine that I have, for example, the train. If there is high pressure under the wheel of the trains, for example, or under the wheels of the trains, then it is more likely that the train is going to sink on the surface where it is. Of course, the train is not going to be into mud, sand, or snow, but this could happen to a car. But this is why I have train tracks, where the tracks and the sets of wheels are going to do what? They increase the surface area, touching the ground, for the same amount of force, because I obviously cannot change the weight of the train, so that is the force. And therefore, because I have the same force but over a larger surface area, the pressure that is being applied on the surface is lower, okay? So there you go. Number 2, heavy cars or vehicles are fitted with tracks or large sets of wheels so that the contact area is as large as possible, making the pressure smaller for the same force. And looking at the other example, so the other way around, a surgical knife is very sharp, making its contact area as small as possible, so that for the same force, the cutting effect, so the pressure that you apply on where you want to cut, is much larger than with a blunt knife, okay? So there you go. In this, in the example of the surgical knife and the nail, I have a very small contact surface area on the place where I want to either cut or make the hole. And this makes that for the same force that either the person applies with a hammer or the doctor applies with a surgical knife, for the same amount of force, I get a higher pressure because contact area is so low. On the other hand, for things that are heavy and I don't want them to sink in, so I want to minimize the pressure, what I do is, because I cannot change the amount of force because these objects are heavy and that's what they're made of, so I'm not changing the object, what I can do is increase the contact area of the object on the ground or on the surface where they are, and therefore decreasing the pressure, okay? And this is because, again, pressure is force over area, okay? So that means that overall, and here we go, because pressure is force over area, if I keep the same size of the force, then for large contact area, what I'm going to have is a large number here in the denominator. So large number for the same force, the pressure will be low. Imagine you dividing a number 10, always 10, by 1, 2, 3, 4, 5. As you increase the numbers that you're dividing 10 for, you know that the result gets smaller. For small contact area, the pressure will be high. So again, imagine now force still to be the same, 10, and then you decrease the numbers of the area from 10 to 1, and you see that the pressure is going to keep increasing, okay? And then if I keep the area the same, so imagine that I do not change the surface area, but I can change the amount of force. So for large force, the pressure will be high, and for small force, the pressure will be low. And again, this is because pressure is force over surface area. And again, now you can put, if you are not very good at maths and seeing these things, you can just allocate the number to the surface area. It could be 10 again, it could be 5, whatever you want. And then allocate other numbers for force. Get them bigger, get them going bigger or going smaller. And you will see that the pressure, the result of the division, is going to be higher or lower, okay? So that is it for today to do with pressure, and yeah, next lesson will be on pressure in liquids, so more to do with pressure but not so much on the basics. And up to my next video, be happy and healthy. Bye.